Hello everyone and welcome to the virtual session from GVG Cloud Bangalore in collaboration with the Cloud Native Bangalore Group. So my name is Ransi and your host for today. And for today's very exciting session, we have someone who needs no introduction among the open source force or the cloud communities of India, none other than Ajit Singh Raina. He is a Docker captain and an ARM innovator with 14 years of solid understanding from a diverse range of IT infrastructure, virtualization, edge computing, DevOps, and DevRel community management. He's also the author of Collabnix.com, which is this personal blogging site which attracts millions of visitors every year. And he also leads the Docker Bangalore meetup community and also the Collabnix Slack channel, where he collaborates and contributes towards the DevOps project. All right, so without further ado, over to you, Ajit. Take it away.
Yeah, thank you, Ransi. Thank you for the introduction. Can you see my screen?
Yes, I've added.
I'm just checking if my screen is visible.
It is visible, Ajit.
Can you
We
please
can see it.
confirm?
It is visible. We can see the screen, Ajit.
Okay, let me check. Okay, fine. So let me go ahead and start with the session. So first of all, I would like to thank each one of you for being here. There are a lot of things which I have been doing, and I think this is one of the exciting project which I have been working on, especially the dronification, cloud native, and IoT, and how these technologies, the different technologies, come together to build up a kind of a robust AI-based analytics tool. So let us get started. A little about myself. I am author at collabnix.com. It's my personal website where I have around 350 plus blogs right now. I write frequently, almost every week, around new features, around Docker, Kubernetes, Cloud Native, and IoT. I am a Docker captain in India, and right now there are around 45 to 50 captains, and we are the captains, are basically a Docker ambassador. We go around, talk about the new features, upcoming features in Docker releases, and then try to grow the community along with the community leaders. I am also Docker community leader. I lead Docker Bangalore meetup group, which today has around 10,800 plus members. I'm also part of ARM Innovator. ARM Innovator are those people who basically has been honored by ARM, and what we basically do is go ahead, try to play around with IoT edge devices, and then try to influence the community, try to bring new stuff around the IoT edge computing. Uh, in terms of professional, I am working as a senior developer growth manager at Redis. So it has been like 2 years I've been working in Redis. So if you go to developer.redis.com, you will see tons of developer content, which are around 150 plus content. So I have been contributing since last 1 year very heavily on those. So if you really want to check out exciting stuffs around Redis, and then especially Redis modules, talking about how to's and how you can use Redis as a technology, so definitely you should visit that. In the past, I have worked in companies like Dell EMC for around 8 years, in VMware around 2 years, and then the CGI. If you are really interested to be a part of DevOps community, I would say just you can Google for Collabnix Slack channel, and definitely you are going to land up in this particular link, launchpass.com/collabnix, and then you get a chance to meet around 6,300 plus people who are there, who might be useful for you to learn about the DevOps technology. Uh, so 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 this is a time where you can go ahead and leverage these community members to learn more about DevOps, cloud native, and IoT technology. Okay, so this talk is going to be really interesting because I am going to talk about four different stuff here. The first thing is the dronification. I'm going to spend time why we are talking about drones. The second one is cloud native. Okay, definitely people have been, you might be in directly or indirectly might be working in some kind of a cloud native application or technology. If not, then let's not worry about it, because I am going to cover a few of the stuff around it. AI streaming analytics. So today I am going to talk about NVIDIA DeepStream, which I have been really working on. So the way the latest release, which is 6.0, there is a support for Redis. So I am going to touch upon uh, like what is the intention of bringing the Redis into a kind of an architecture. And definitely one of the thing which you have seen in the right is NVIDIA Jetson and Xavier, right? So these kind of an IoT AI computers. So I'm going to touch upon that. Okay, so let's talk about an interesting stuff, because we have been talking a lot about drones. So one of the thing why I introduced this topic is the reason being there has been a lot of queries around, okay, can we fly drone in India? Uh, and because mostly the drones are used for the commercial purpose, but at the same time, can we use it in the indoor, or what is kind of a limitation from the government and all these things. So I have 2 or 3 slides which talks about the civil drones. Okay, so now let's start with some kind of interesting facts, and I don't know how many of you are really tracking, but this is really interesting to know that the commercial drone market, as per the FBI, is they what it is basically, the stat says that it is expected to reach 6.30 billion by 2026. Now you can look at how drone has been affecting in number of, not just in a military but also in the commercial as well as in the personal field, right? And the other interesting fact is, there are close to 30,000 drones are registered in India. Now, when I started reading about the drones, I was so curious to know like what people are really doing around with it, what kind of stuff they are experimenting with these drones. And this is one of the prediction made by I think a civil aviation ministry is like by 2025 India is anticipated to be the world third largest drone market. Now when I read about these kind of stats, I was a little curious to know that what people are really doing with the drone. And that made me start with few of the projects last year. One was Cherrybot, which I'm going to talk about maybe 1 or 2 slides around it. But that was more like the two kind of offering there, the terrestrial as well as the aerial. And in terms of aerial, the drones were the the important pieces there. And today in this demo I'm going to show you about, I'm going to show you about the DJI drone. And that's why I mentioned, and you will be really surprised to know that DJI covers around 80% of the market for drones in US. And I can see slowly and slowly people are trying to use such kind of a drone, not just for the photography. It is also for kind of an exploration they want to do, right? Especially in agriculture and all. So I prepared one of the kind of a slide which I took from the internet, saying like, now you might be curious about like where these drones being used. So this is a kind of an estimate, and this is especially the Drone Federation of India. They have published a paper saying like 30% of them are used in defense and homeland security. Now this was interesting piece, but I was more interested to know about the second field, which was like agriculture. Like 20% has been, 20% is a huge, okay. And they have been used in the agriculture, and I could see there are a lot of blogs and tutorials which are written about, okay, how we can go ahead and use the drones in agriculture, right? How you can predict this the moisture in the soil, right? So all of these things. And the next 20% is for the agriculture. In the same way, the mining, there is like a 5% of them is used in mining. And then a bit surprising for me, because usually when you say drone, it was more, the more use cases have been in the aerial cinematography and the photography and all this thing. But it is interesting to see like only 5% of them. So my curiosity led to like, okay, if I want to go ahead and play around with the drone, definitely it is like now you can get it, you can order it from Amazon. But definitely if you are looking out for like a very specific kind of a drones like a DJI, still you need to get it from the international market. And one good news is, as based on the recent, the announcement which was made, like earlier, there was a limitation of around 249 gram. That should be the weight of the drone which you can fly, but now it has been, the government has increased it from 300 to 500 gram, especially kg. So this is really good, but still for the indoor kind of a drone, you can still, the one of the thing which I am going to show you here is like the Tello drone which I have been using. It's just like an 80 gram. So with such kind of drone also, you can do a lot of exploration. But this is something which I prepared for you guys to see about. We need to aware of the rules and regulation before we can just go ahead, because these regions have been divided into the yellow zone and the green zone, right? So if you are in a Bangalore and if you are near to the HAL, you can't just go ahead and fly the drone. You need to have a proper permission for that, right? So we should be aware of it. Now, for my project, especially on the object detection, AI analytics, and using it with the IoT Edge, the drone which I have been using at DJI Tello drone, which is quite affordable. It is like $99 indoor quadcopter. You can control it through the Python programming. You can also use a Scratch, and then it comes with the Intel processor. It is 80 gram in weight. It flight time of 13 minutes. I think it is more than enough for anyone to go ahead and test or explore things. Because I have been using it in one of the prototype when I am working in Cherrybot project. But one of the things which is exciting is, yes, it has a maximum flight distance of around 100 meters, which is more than enough if you really want to test something, right? And it supports Python. The Wi-Fi is one of, I think, the brilliant feature which has been introduced. The reason being, once you switch on the drone, it basically becomes a hotspot. So let me show you how this Trello drone, a kind of a sneak peek of the how the Trello drone look like. So this is how it. Let me turn on the music. Okay, so let's move to the next one. Let me go here. Okay, now you might ask, like, there are dozens of drones in the market, like why you picked up Tello. The reason being, it supports Python. Now, most of the AI based applications using Python is quite popular, and I was looking at some kind of a drone which can do a kind of an object detection and analytics. So rather than having a Jetson board with a camera module connected, and but for certain use cases like in object detection, where say if you are in a mall and you really want to go ahead and detect how many people are wearing the mask, like one way is you fly the drone. It will take a snapshot of 30-degree flip. It will take a snapshot and bring you all the information, right? Now, the reason why it supports Python is because there is a Python SDK library. So if you go to the Google and type DJI Tello PY, you will get basically this SDK file which I wanted to use it. Uh, it basically helps you in implementing all the stuff which I'm going to show you in kind of a demo. It can do the video streaming. It can capture the picture. It can you can instruct the drone to fly in the air for a certain time. So all of these things, and this is a pip install DJI Tello. So that's what you need to do, and you can install it on any of the Jetson board or in the laptop if you want to control. So these kind of a drones can be controlled through the mobile devices as well as from your laptop. So one example of the Python code to connect and fly the drone is right here. If you see a very simple code where you are importing this SDK and instructing the Tello drone to connect, take off, and then land. So it is very simple. And then if you want to do some kind of a movement, you can still go ahead and do it. So let me show you one of the example here. So this is an example, maybe. Okay, so let me show you the quick demo here. So right now I have this Python script which imports the SDK, instruct the drone to connect and take off. And once you run this command, I will just go ahead and try to run it. So this is a kind of the live demo which I have recorded during the instance, and you can see the command, how the command has been sent. So now this happens once you make your drone a kind of hotspot, right? Once you hotspot, so we instructed that the drone has to fly, be on the air in the air for around 5 seconds, and then come back to the original place. So this everything is being controlled by the Python script. So you might know, like if you have a DJI drone, you can control it through the mobile or any of the devices, right? But this is purely through the Python script. Okay. Now, in the other example, which I am going to show you, is especially the mission pad detection. So pad means the helipad. Like if I really want to instruct the drone to fly and then detect and then land on, on the same pad. So that kind of a control, you can do it. In the same way, you can capture the picture. So this is a Python code to go ahead and capture the picture. And then you can also, what you do is record a video. So this is a particular code. I'm going to share it on, I have all this code in the GitHub, which I can share it with you. But the whole idea of showing you is like, we do have a Python code to control the drone in multiple ways. And that's why, and this is going to be a very useful for application which we are going to build. Okay, so this shows about like how the drone is making a movement. So you see here there is a Jetson Nano. I'm in running a command on Jetson Nano and then trying to connect to the hotspot. I'm going to show you an example where it does a fire detection. That's why you see a kind of a television where I have one of the recorded which I have placed, because in the COVID situation I just can't go out. So that is the reason I try to have a very kind of a example where I can go ahead and control. So the Python code is so powerful that you can control it within. You can do a 360 flip. You can instruct drone to go ahead and make a circle around it, and all of these things. This is possible today. Now this is one of the example where it goes ahead and circle around. If you see, the drone is moving among slowly and slowly around itself. So those kind of a control also you can do it. Okay, so going to the next session will be, okay, so let's go and talk about. So we talked about the dronification, right? How you can use a Python code to go ahead and control the drone. The second thing which I want to talk about is an AI streaming analytics. Now this is really important. The reason being, say you capture a video and now it has to be processed, right? There should be some kind of AI workflow which has to be implemented. And so this section I'm going to spend for next 5 to 10 minutes on AI streaming analytics. Now, today, if you look, AI is being used in multiple areas like smart infrastructure. If you really want to go ahead and detect how you are going to mold the traffic, right? If you have a huge traffic in the city, you can use such kind of a cameras. It's not about only the CCTV camera, but CCTV camera plus AI, right? In the same way, in the retail shop, when you go right there, you could see now the robotic platforms are there to help you out and search, and even your shopping cart with AI devices inbuilt into it, so that it can go ahead and detect and it can calculate what are the objects are or the stuffs are inside the shopping cart. In the same way, in the healthcare robotics platform, even in the call centers, right? When you get an automated response, and based on that some kind of an execution happens in the background. So in one or many way, you have all of those AI visions, speech enabled services, natural language processing, right? All of these things use, even if you say you spend so much time in a Slack or Zoom, right? We have a bot. So that is one way of AI stuff which has been implemented, so that they know like what is going to be the next step, how the response is going to be, right? Now when you look at the typical AI, it basically every AI analytics has some kind of a workflow. Typical AI workflow look like something like this. So every organization doesn't have the data. Okay, for this kind of an analytics, you need a massive data. So that's the reason why. Like one example which I can give you, that very recently I've been working on. NVIDIA GPU cloud. Right now they have the pre-built or pre-trained model library, which they have been shipping it in terms of even the Docker container. So if you have ever used a deep streaming Docker container, it has sample application inside it, and it gives you a kind of a pre-trained model data, right? What you need is a data, right? So the object detection, facial recognition, and then gesture, and then text recognition. So all of this, when you start playing around with the AI, you need the huge data, and that is where you have a certain pre-trained model library. Now there are a lot of open source solution out there in the market, but at the same time, if you really want to, one of the thing which is really important is, optimization has to be done. So you really need to have such kind of a framework which you can use to go ahead and train it, adapt it, and optimize it. And that is where your data has to be properly trained. And once it is trained, then most probably the next step would be how you take it to the production. And that is where you need to go ahead and deploy it, right? Taking the scalability and all of this thing in picture. Now the challenges with streaming the AI development is, like, I can bucketize into three forms. The first thing is the design complexity. So when I started playing around with it with one of the Python developers, one of the thing was like which tool you should pick it up, because there are so many tools which are available, right? Even I would say, like, look at the different frameworks, right? All the frameworks, like PyTorch, TensorFlow, Onyx, and these has been developed by different companies, right? And which one to choose? And if you are really looking at open source, then the complexity is more, because these are like a bits and pieces. They are not provided as a complete solution. And then you have all of these frameworks sitting on a, built by a different programming languages, right? So there could be Java, it could be Python, and now the more confusion is you have a more complex design, AI framework sitting on more complex programming languages. So that is one. So it shows like there is a kind of a design complexity. The second thing is you really need to go ahead and build it in such a way that it has to be a very cost effective. At the same time, you don't want to spend, say, millions of dollars to implement this. Like, it has to be within the constraint of the cost, right? That is also important. And the third thing is, if you are building such kind of a solution, then most probably it should meet with the, say, whether you are doing it for x86 or ARM 64. So those kind of complexities are also there. So if you look at most of the packages which you have built on your laptop is not going to work on NVIDIA Jetson, because it is an ARM based, right? So whatever the Docker containers which you are building on your laptop is not going to work on the edge devices or a Raspberry Pi. So you need to build it. So whenever you are building such kind of an AI solution, you have to ensure that those runs everywhere, right? Or it has to be supported. Now, this is a very good example of how the streaming AI application look like. You collect the data from the sensors. The first thing you do is you capture them and decode it. You do some kind of a pre-processing into it, and then you train the model. At the same time, now once the model is trained, now it start making the prediction, and that is where your AI inference come into the picture. And once your data, the prediction is made, that has to be tracked, that has to be the metadata which you collected has to be sent to the cloud. And then based on that you make an analytics. So one example which I could say is a face mask detection. If you are building such kind of a solution, right, it is important that you just don't detect it, right? You count how many people, you do some kind of analytics on top of it, and for that analytics you need metadata, and these metadata are sent to the cloud for further insight. Now, one example which I want to talk about is one of the AI computer, which is Jetson, which is like a $59 for 2 GB, like 2 GB configuration. We have a two models, 2 GB and 4 GB. And then even though there are multiple solution, but this is very cost effective solution which you can use it. The beauty of this product is it comes with GPU, it comes with Docker pre-installed. So it runs on SD card, it runs on USB storage device. So there's a lot of flexibility. And then you can run all the AI based application on top of it. You can use, like, say, minimal 16 GB to 512 GB of SD card. We can use it with this device. And you can see here on the picture, um, uh, right now it is just like I have shown you the SD card. You can install the whole OS sits on the SD card. Even you can connect it and connect the USB device, and you can run OS on top of it. So it is the GPU. If you look at the configuration, especially 128 core GPU you are getting with like $59, it is like super impressive. The 2 GB RAM, Um, one other thing which is missing is like it doesn't support Wi-Fi, so you need to have an external external module into it, for the Wi-Fi module into it. It supports USB C port and all this thing. And on top of these devices, there is a specific Jetson stack which NVIDIA has built. So if you look at the whole complete, one of the beauty of this is like if you pick up the Raspberry Pi and all, you have to, it's kind of a DIY, right? You have to build it from yourself. But Jetson provides you with all the necessary stuff which you want to build an AI-based application, which means that you are going to save a lot of time. So if you look at the software stack, it starts with the Jetson. On top of it, you have a CUDA. CUDA is like an interface which allows your hardware, especially say your Docker container want to talk to the GPU. So CUDA is going to help you out. You need to have a CUDA package, and on top of it, you have an SDKs, right? This is important in terms of implementing all sort of deep learning, multimedia accelerated computing, computer vision, OpenCV, and all this thing. And on top of it, you have a DeepStream SDK, and that is what we are going to talk about today, because the whole solution is based on the DeepStream. And now these kind of, when you have a very robust stack, then you can build this kind of a solution for multiple ecosystem like city, factory, logistic. Okay, now there are four different Docker containers which DeepStream comes with. The first thing is, the base Docker, which has the GStreamer. That is basically the foundation for DeepStream, uh, which helps you to convert it into the AI analytics part. And then you have a DeepStream test 5 apps. There are some kind of a sample apps which you want to use it. And then there are certain developer libraries, and the inference. So Triton is basically an inference server where your machine, once you trained it tries, it start predicting around like what is going to be next, right? So all of this thing, or it does an object detection analytics. So if you really want to go ahead and use it, so this is not in the Docker Hub, but in their own, NVIDIA has in their own registry server. They call it as an NVCR, and you can just pull it and you can start, using it. Now we talked about dronification. We talked about IoT Edge. Now one thing is how it connects to the cloud, right? And that is where this is a particular diagram which I want to focus on. The thing is, yes, on the left hand side you see there are input sources, and we have a DeepStream application, and this DeepStream application has a very tight integration with all the leading cloud vendors like AWS, Azure, or any public or private cloud. The message broker which you see is basically, we are talking about the producer and consumer. So think of it is like you have a solution where your Raspberry Pi connected to and camera module is a producer, and then your AWS Lambda is one way of consumer, right? So, and in between you have a solution like a Kafka or a Redis PubSub, which basically act as a message broker. So the Raspberry Pi captures the video frames, send it to the Kafka or Redis or the PubSub, and then it basically goes ahead and trigger the AWS Lambda. So in the same way, we in between we have a DeepStream now, because we are implementing everything on the IoT device itself. So the DeepStream application is going to run on your Jetson Nano. It is going to send all the metadata to the cloud for the further analytics. So one example I could show here is the DeepStream 6.0, which was introduced very recently in the month of November. So you see here all types of capture, decode, and stream management will be done by the DeepStream app. And once the inference is done, then those kind of metadata will be sent to your consumer, especially to the consumer. Okay, and that can be implemented. Either it can be on your like just on top of Jetson board, or it could be on the cloud. And that is where you can use solution like Kafka or Redis PubSub, which is supported by DeepStream today. And this is the whole kind of a cloud native application where you are connecting the IoT edge to the cloud. Okay, so enough has been talked about the theoretical. Let's see, especially one of the example which I was working on is a fire detection using drone, Jetson Nano, and DeepStream, because now you bring all the three technology in one place. And the thing is, like, to test such kind of fire detection system, to build such kind of fire detection system, you need to be especially the outdoor, so that you can get a real picture. Like, because of the COVID, it restricted to go out. So what I thought is, why don't we go ahead and test it indoor? And that is the reason I opted for Telodrone as a prototype. The reason being, uh, uh, as I said, right, I was working in some kind of a robotic platform, and I wanted to test both the terrestrial and the aerial, and that is the reason I picked up Telo. Now let's look at the when you start, building something. One of the constraint is what is going to be the budget. So when I started working on it around 2 months back, the hardware requirement was the first thing when I started listing. So you have a DJI Telodrone which cost around $99. Uh, Definitely, I won't recommend you, but this time, I could not get it from Amazon or Flipkart, so I have to rely on India Mart. I never recommend you to go to them and buy it, because you never know the source is going to be. But I needed it badly, and so hopefully, like, it was shipped within 3 to 4 days. But I would recommend, if you really want to go ahead and buy it, either you can directly go to the DJI, or you can go to the Amazon or Flipkart and buy it. So DJI Teledrones comes with two batteries, and the propeller. They gave a kind of a backup, like 4 pieces of propeller to you, and it cost around close to around $99. So you need a Jetson Nano 2 GB. This solution why I picked, because I wanted to keep the cost low. um, but I do have a Xavier which cost around like $60,000, so those kind of a solution can also be used. But for this prototype, 2 GB is more than enough. If you really have running constraint, you can always go ahead and convert it. You run it on the SD card, at least, which has like 128 GB. So you have SD card, Wi-Fi module. Jetson doesn't come with a Wi-Fi, just like Raspberry Pi, which has inbuilt Wi-Fi, right? Jetson doesn't have, so you need to go ahead and buy Wi-Fi module. For Jetson, it is not going to work on any of, below the Type C cable. It is not going to work, so you need at least a Type C, and on top of it, it should be like 5 volt 4 ampere. So it's a very special adapter which you can order, and that should be sufficient. And DeepStream 6.0, which has been released very recently, it is free of cost. You can download it. It is completely open source. Now I want to test it, and one of the fancy stuff which I did is, especially my son, he said, like, why don't you go ahead and run some kind of YouTube video on top of it with the fire, and then we are going to test it. So the first thing which we did is, we had created a very, like, we took a mouse pad actually, and then put a Telodrone. So you can just imagine like how small it is, and whatever you see on the left hand side of the Telodrone is nothing but Jetson. You just have to power it on. Wi-Fi module has been inserted in terms of USB module, and then you can always control it to the laptop, right? Now, the first thing which you do is you power on the drone, and once you power on the drone, it is configured as a hotspot. Okay, and you run the Python script, and it starts flying. So you can see here the image where it is just flying, and then the whole focus is on you have to ensure that the camera, you can control it, right, and you can see it live on your laptop itself. Now, once you do it, then you connect your Jetson Nano directly to the Telo, and that you can do, just you have to go to the kind of select the Wi-Fi, get it connected. Now during this time, your connectivity with the internet might fall down, but you need to go ahead and test it one by one, right? So once you connect it, there are a couple of Docker containers I have converted out of those Python script, and these containers has to be configured with GPU device, which means that you need to have a CUDA, you need to have a CUDA and NVIDIA runtime up and installed on your Jetson board, right? And then you can do all sort of things like flying drone, taking pictures, recording video through these containers. Now, once you do that, the Telo drone is going to go ahead and push the content in terms of UDP, and then you need to convert it into the RTSP. Now, that is why we are doing it, because we have to supply it to the DeepStream, right, container, right? So that is the reason. So I created a kind of a container for that, which is basically called the stream conversion. It converts the stream and send it to the Jetson. Now this is how it is going to look like. The RTSP is the protocol. You can open it through the VLC. You can use the VLC, and then you can access it. Now, the next step would be using the NVIDIA DeepStream 6.0 container. So right now I use this samples container because it comes with YOLO, as a sample app. So it was not much difficult to go ahead and implement it. And the next thing which I want to try with 6.0, for the first time, they introduced Redis as a support, right? Earlier it was like only the Apache Kafka and other message brokers, but I was more interested to try the Redis 6.0. And I can see a screenshot where because at this point of time, it is so difficult to go ahead and show you the real demo indoor, because it took, we need some kind of a space here. But DeepStream contains your runtime library, GStreamer plugin, which you require. It's kind of a foundation. And then you have a reference application. So at this point of time, you won't get it as a fire detection kind of an application. So this was like one of the open source application which I worked on and found it really interesting. I'm going to share it at the end of the session, but there are few models which are available which you can use it, which are mostly implemented in terms of connecting the camera module like to your Jetson. But we really wanted to test it with the Tello drone itself. And then the YOLO V3 model, it detects the fire, and since it is plugged into the DeepStream, you need to go ahead and build it. Actually, these are kind of a sample application, but it is not inside the Docker container. They are like more specific. So especially if you look at the DeepStream, there are specific the 4 types of containers. It doesn't fall under the sample apps. You need to go ahead and build it or leverage the open source, which is available in any of the GitHub repo. Now, once you convert the UDP to RTSP, the next step would be you need to push it to the Redis, and because that is where we want to push this metadata to the cloud, right? And that is the reason where here you can use. I used Redis Enterprise Cloud, which is like a free for around 30 MB. So, but in your case, you can always go ahead and use the open source version or Redis mod. Again, Redis can be installed on your Jetson Nano. You can compile it. If you really want to run it today or compile the modules like Redis AI, do check out Collabnix. Just go to the Google and say Collabnix plus Redis AI. You are going to see the blog. But the whole code here is the Python code shows you about, it's talk about the RTSP, how the UDP and RTSP gets converted into the RTSP. And after that, you should have a Redis server running on top of Jetson Nano, and that is going to push to the Redis. And you see here, it has successfully detected like it is a fire. Okay. And then those kind of data, how many places. So what we did is like we played a couple of, there are 3 laptops, we played a video and then try to collect all those data from all those the 3 laptops, and then sending all those data, like how many places does this fire detection has been done. And the way how it works is, it basically your drone going to collect the image from the web and use it as a data set, right, to train your model. Then you have a trained model which is compiled with a darknet, okay, on your desktop. And then YOLO V3, which it could be a desktop, it could be a Jetson, but if you really want to do an analytics kind of if you really want to run DeepStream, you need Jetson with GPU, otherwise it is not going to work, right? And one thing which is really important is you need to be very careful in picking up the jetpack, because for every deep stream, there are certain conditions where you need to have a jetpack 4.3, 4.4, and all of this thing. And then there are few of the links which I refer to, like how the YOLO model worked in DeepStream. So I am going to share you the complete repository. I have put it on one of the project called as a cherry bot. So I am going to do that. But usually when you install it on your Jetson Nano, not in a container but on your bare metal machine, so usually all of these YOLO sample apps, YOLO based sample apps get dumped into the OPT NVIDIA DeepStream. So, and this is an example of DeepStream, old the DeepStream, but it should be like 6.0 should be there. Now, this is one example where I have, when you collect all those images and put it in the Redis, this is like, I was trying out whether to see whether it, because Redis is a kind of a key value pair, right? So this is a screenshot of Redis Insight, which is the Redis GUI. and I was able to go ahead and try to see whether the data has been inserted into the Redis database or not. Again, Redis is used as the message broker. Let's not forget that. And then for that, you have producer, you have a consumer, and how it is being consumed. And whatever we are talking is more like a metadata. This metadata gets stored into, you can push it to the cloud. Now, this Redis database can be run on any of the cloud, AWS, GCP. So there is a support for all the clouds. And then after that, what you can do here is, and one thing which is in my to-do list is, if you can plot it over the Grafana. So that is the next set of the thing which I am like thinking in terms of the future work and reference. So this is a cherrybot.collabnix.com, testing the overall solution with which I just tested with the one set of one Tello drone, but my idea is to go ahead and try to see what are the possibilities. So if you can do a fire detection kind of a solution, think of it as like a mass detection system which you can implement right within, like using the two containers, one controlling your drone and the other controlling the whole AI analytics pipeline. So you are going to build up a kind of a very robust kind of a solution, right? And then the next thing is, if you really want to go ahead and push it to the time series database like Redis time series, which can give you an information about how many people or how many places the fire has been detected, or how many people are wearing the mask or not. So those kind of things you can go ahead and implement it. So I am towards the end of the session, but one thing which I want to say is like right now, as an ARM innovator, one of the things which has really benefited me during the testing is, I know one of the challenges which we have, especially the students or the university students or college students, right, has is like the availability of this hardware. So there is a program called as Works on ARM, which is in collaboration with the Mini Nodes, which basically host the IoT. They are into the business of hosting the IoT devices. So they came up with a kind of a solution, because this is one of the problem statement which I had last year when I was working with few of the students. Like they don't have an access to these hardwares, right? Especially the Jetson, Nano, as well as Xavier and all this thing, because of the cost. And what the Mini Nodes and the ARM has done is, they have come up with a kind of a GitHub repo. So you can just record it, github.com/works on ARM/mini nodes ARM edge. If you go there and raise a request for getting an access to one of these boards, definitely they are going to help you out. So I needed two of the systems, the Xavier system, and it just took around 2 days to get me that hardware. So I would recommend, just go ahead, raise an issue, and start playing around with these cool devices, because there are like infinite possibilities or the use cases around how we deal with, say, DevOps tools, cloud native applications, as well as the IoT Edge and the dronification for sure. So I think I am done with this, and I am going to stop sharing my screen.
Great. I think that was amazing, Ajit. I mean, that was so wonderful and a very good overview of how these three cool tech can come together and then, just collaborate to build some cool stuff. Very informative to watch, and I'm sure everybody found it really insightful. So with that, we can open up for questions. So for everyone who's just watching in, please do drop in. But we do have something right up to get started. And first one is like from Neha, which is sort of like I'm going to pop that up on the screen to know the challenges that we faced in building this.
Okay, so for sure, the first challenge was the hardware availability. So when you start with some kind of IoT based applications, the first challenge is the cost and then the availability. So when I started playing around with it, it was more like a terrestrial, and I wanted to get an access, especially with the JetBot, but there was a lot of challenges. And at the end, we need to go ahead and build it one of our own. The reason being, JetBot is again, the problem is in availability, in shipment, and all of these things. So the first challenge is availability. The second challenge which I have is, usually most of the application which we built, we try to containerize it, And sometimes what happen, like especially when you're dealing with the OpenCV library and when you try to compile it on the Jetson Nano, if you are picking it up from ready-made kind of a stuff from the internet, so it becomes very easy. But if you have to build it of your own, that becomes a problematic, because before you containerize an application, you have to test it on your bare metal system or on these IoT devices. You need a particular libraries to test it. The third reason being, definitely you need to look at the integration. There are sometimes the limitations. So when I was playing around with DeepStream 5.1, there was no support of Redis. So that was the complexity, where how you can go ahead and when you look at the Jetson stack itself, right now, these are there are certain conditions. Like, think of it is like, you can't run, say if I want to really go ahead and use Jetpack Manager, that doesn't work on your ARM 86, ARM 64 devices. It has to be only run on the Windows. It supports only the Windows. Now getting a Windows platform was difficult, because it is now the limitation of that particular hardware on those particular kind of a compilation, right? So that was a tough stuff for me. The second thing is, sometimes what happen, when you play around with it, these containers are very large in size. They are like built in terms of kind of a monolithic application. They are not bits and pieces. So if you look at the DeepStream, it might be like a gig of size. And if you have say if you are trying it on 16 GB size memory, definitely there will be limitations. Now the last blog which you look in my site is one of the problem statement my friend was facing. He has a 16 GB of SD card where he wanted to run a DeepStream. Now he didn't have any option, because the reason being, now he can't wait, he have to test it as soon as possible. And then I helped him in, why don't you go ahead and use USB storage. And he had like a USB storage of like 128 GB, right? So I went ahead, we looked at the forum, NVIDIA forum, and then we found some kind of a tool called as boot from USB. We just picked it up, tested it. So those kind of hardware limitation is what you are going to face. Yeah, these are the other few of the challenges which I faced.
Okay, got it. So I think it's mostly the hardware related challenges is what you could
Correct.
summarize mostly.
Yeah.
Yeah. Because
Yeah.
software could be something that we could work around a bit.
Correct.
Right? Okay, good. So, yeah, the other one is like a very generic question that is like, is Redis similar to InfluxDB? That's like a more of a generic question.
Okay, so I haven't played around with InfluxDB a lot, but usually if you look at Redis, Redis is can be used in terms of your Redis is popular in terms of only the caching solution, but one of the thing which we really need to understand is it can be used as a primary database as well as message broker too. When you say InfluxDB, it has something to do with with the time series kind of an entry, just like a Prometheus, right? Where you have a data coming in with a particular speed and you want to ingest it and store it, right? So Redis in under the Redis, I think the right this is kind of Redis to InfluxDB will be more like an apple to orange comparison. But if you really want to compare it, you should compare it with in terms of Redis time series and InfluxDB, because these are both the databases which stores the timestamp data. So InfluxDB is more like a it stores the time series database, but Redis can store time series, JSON. Even we have a Redis AI module, which we can, you can use tensors in it. And then we have Redis JSON, which it can store the JSON type. We have Redis search, Redis graph. So the right question would be, what is the difference between Redis time series versus InfluxDB?
Got it. Yeah, I think that's a very good explanation, Ajit. Yeah, I think thank you. I guess that's about it. I don't see any more questions trickling in. So I guess we can call it a day and then probably until we catch up the next time. So you have any final words or to the community?
Yeah, and first of all, I would like to thank you for inviting me. Definitely, this is the first time, I have been talking in any of the Google developer, as well as like I see you have been posting in three other meetup groups. So definitely, I could see there's a lot of excitement around the community, and it's great to be here. Thank you for the invitation. And one last thing which I want to say is like, look, uh, like, you might think, in day-to-day activities, we have been involved in certain kind of a solution. But one of the things which I would suggest is, even if whether we are in the DevOps world or any of the other communities which we have been leading it, but such kind of a solution and such kind of there is no limitation to any of the possibilities. Like, you can do ample amount of things, and if you really want to go ahead and contribute for this, I always welcome that. And even if you see, we do have a Slack channel where you can go ahead, reach out to me. And I'm definitely, whether you are a college student or you are working professional, feel free to reach out to me. And definitely I look out for more like a collaborative effort. And the next time, maybe one of you could join me in the same talk, and we can talk about all the new stuffs.
Excellent, excellent. I think that's like a very hitting message to the community, and it takes the right spots to me because I can personally vouch that you've been like a very good contributor to the Collabnik Slack. I see your messages. I personally am part of the Slack community, and I see a lot of collaboration and effort, and I see a lot of comments from you for most of the messages that are actually posted over there. So I
Yeah.
think thank you from myself for that, and also thank you from the GDG Cloud community for being here. And it was tremendously honorable for our end to host you. And we definitely look forward to see you in the future in
Thank
something.
you. Thank you, Rinshi. Thank you,
Sure.
everyone, for
So with
attending.
that, we are signing off, and everybody just stay safe. And until next time, it's me signing off. Bye bye.